So, essential question, we're going to graph an equation using a table today. So, when we have a table, let's put in the middle the expression that's dealing with x. So what I want to see in the middle is whatever y is supposed to equal. We're going to start with the x side because it's going to take less thought if we start with the x side than starting with the y side. We would have to do a lot more guessing and checking. So let's pick some x's. So let's say I do choose 1, 2, and 3. I'm going to plug them in. So I'm going to take 2 times the 1 and subtract 1. So 2 times 1 is 2. Take away 1. We end up with a y coordinate of 1. Continue on the process. Graph the point 1, 1. Graph the point 2, 3. Graph the point 3, 5. 3 on the x-axis, 5 on the y-axis. Let's recall how to graph these points. So after we graph the points, we're going to graph a line. Since this is a review, you can try it on your own. If this denominator, so to strategically try points or try numbers that will get rid of this denominator, you've got to find numbers that are multiples of that number. So whenever we say evens, all even numbers are divisible by 2. So let's try to plug in some even numbers. The lowest even number, shouldn't say the lowest even number, but 0, 2, 4. If I plug in even numbers, that will make that fraction become an integer. So when we try even numbers, the denominator keeps becoming like a factor of 1 or keeps cross-reducing. And we end up with integers. Not saying you can't plug anything in, just in case you want to get rid of the fraction. All right, let's graph them. With this one, if I want to get rid of the fractions, I'm going to need multiples of 3. So, trying out 0, 3, and I'm going to show you what a negative 3 would pop out. If I take 2/3 of 3 and then subtract 2, 2/3 of 3, what's nice is, well, we just get a 2 in the end. Subtract 2, we're now at 0. If I take 2/3 times negative 3, the 3 still can't cross-reduce, but now you have 2 times a negative 1, giving us negative 2 minus 2. So we're at negative 4. After we graph the points, let's connect them. So even if you chose 6, it looks like if you did choose 6, probably would have been at 2.
At this time, will the
So plug in any numbers. Let's say I'm going to try -1, 0, and 1. If you chose other numbers, don't fret. Again, in the end, if your points connect and create a straight line, then you're still okay. So, -1 times -1, get a positive 1. -1 times 0 gets us to 0. And -1 times a positive 1 becomes -1. So with this equation, y equals 5, we got to think about yesterday. How do we interpret that? All of the y coordinates are 5. So no matter what I plug in, it doesn't matter what I do with x, all of the y coordinates better be 5. It doesn't matter what we pick, as long as all the y coordinates are 5. Let's graph it. Let's do a little what if. What if we had this? So if we had a table given to us, maybe on our test or whatever, it doesn't matter what happens on the inside. All the x coordinates better be -1. If we pick some y coordinates, let's just draw a sketch of where these are at. So -1, 3, -1, 4, -1, 5.
This is undefined.
It's an undefined slope. I want to make sure that we understand if we can see if we start embedding it in our brain, if I see x equals 1 and I'm asked to graph that, if we can interpret it as all the x coordinates need to be this, or all the y coordinates need to be that, we don't have to memorize if it's a vertical line or a horizontal line. We can make sense of it a little bit better.